Hi, today we're going to talk about standard deviation, and I'll show you the practical meaning of it and how to calculate it. I'm doing this video because I have seen over the past 15 years students getting confused about what standard deviation really is. So I decided to show kind of an official definition, a formal definition of standard deviation here. And usually books or websites like Wikipedia will say that, yeah, standard deviation is the distance from the mean to the actual value. I wouldn't take that really as an important thing, and that's because it's not quite precise. Let's look at properties before I show you the practical meaning of it. Okay, whatever the standard deviation is, one very important thing about it, very important, it comes in the units we measured the data. Okay, why is this important? Well, think of it. If you measured height in inches, let's say the average is 79, the standard deviation is 2. That number 2 means 2 inches. Okay? It's an important thing you'll see in a minute. Now, in practical terms, what is really this standard deviation? Well, you'll be surprised. It's much simpler than you imagine, and here's what the standard deviation really is. The standard deviation is the average of the errors. That's what it is. So every process, let's say you are going to make cookies. So in the process of making cookies, if you take the weight of your cookies, you see that they differ a lot. Some cookies are much bigger than others. So the process of making them creates these errors. Now, if you have all these errors, each cookie has a certain size of error, there's an average of errors. That is the standard deviation. Okay, so it's important that you remember that the average of the errors is what really a standard deviation is. Now, let's look at a little problem that I prepared here. A factory makes temperature resistant hoses for car motors. A certain hose was specified to resist 240 Fahrenheit before catching on fire, of course. So, what we do to find the standard deviation? We go to a factory, we pick up some hoses. In this example, we took 3, but usually you take about 15 or 20, not only 3. So here we took 3, and we're going to find the standard deviation. Well, we know that the standard deviation, let me make the font a little bigger here. Okay, the standard deviation is the average of the errors. But to calculate it, first find the average of all measurements. We need that average first. So there we go. We take the hose and we're going to measure how much temperature they resist. So we take them to a lab, we heat them, and at the point when they start melting, that's the melting point, and we don't want the hose to reach that temperature. So that's the max a hose can take. So let's say the first hose melted at 260 Fahrenheit. Okay? We take the second hose, heat it up, and the second one melted at 240 Fahrenheit. And we go for the third hose, and the third hose melted at 250 Fahrenheit. This is Fahrenheit. So here is the numbers we have, the measurements in Fahrenheit, and they are the melting points of these hoses. So we need to find the average of all measurements before we can find the standard deviation. So how do you find the average? We just add these three. Okay, so it'll be 200, 400, 600, 750. Okay, now we divide by 3. Okay, we take the 750, we divide by 3, we're going to get 250. Okay, so the average of this sample is 250. We call it X bar, and we say 250. X bar is because this is a sample. Okay, by the way, there is no two lines under it. So we have this average. So this is the average of our measurements. Now, how do we find the standard deviation? Well, the standard deviation is the average of the errors. So what is the error? Let's make a line. Here's a line, and we're going to say this line is 250, which is the X bar. Okay, so let's look at the first hose. It melted at 260. So I'm going to put a dot here, and we're going to imagine that at this height above 250 is the line 260. Okay, so now we can see that the first hose did not melt at 250, it melted at 260. So this red distance is error. Now, one thing you should not think is that, wow, this is a very good hose, it melted above. I want my hose to melt all the way above 250. That's incorrect thinking, because it should not melt above. They all should melt at the same point. All right? Error is error. There is no such a thing as good error in statistics. Okay? Now, let's look at the second hose. The second hose melted below 250. 250 is the average of all three. It melted below. It melted right here. And this is 240. So the first one was 260, and this is 240. So this hose melted before getting to 250. This is error. Okay. Now let's take a look. This error here was plus 10. The hose melted 10 above, and this is minus 10. If you add these two errors, how much error do you have? Well, mathematically, the 10 positive cancels the negative, and there's no error. We know that's not true. There are two errors instead of no errors. So you'll see in a minute why we square numbers in statistics. Okay. Now the third hose melted at 250 exactly. Okay. So now we have three holes, and the error on the third hose is 0. Okay. So we have that situation, and now we're going to find the standard deviation. So the standard deviation is the average of errors. So how do we find the average? Well, at some point we have to divide, but we don't divide by 3. 3 here, we call it n. So instead of dividing by 3, we have to divide by 3 minus 1, meaning we divide by 2 in this case. It's a long story why n minus 1. You can Google it and find it, but it's a long story. I'll just show the formula. The average is n minus 1. So we know we have to divide. Now, what is it that we are dividing? Well, we're dividing the error. So how much is the error? The error is each value we have. Here are the 3 values. Okay, each one of those minus the mean that we found. Here's the mean, 250. So that mean we called X bar. Now, we're going to take each one minus the mean and divide. The division happens later. Actually, we add first. So what we want to do here, we want to take this difference. We found plus 10, but we cannot just add to this difference because they cancel out. So to avoid the canceling out, we're going to square. So now the situation we have is this. We have that 10 but we square it. Okay, so I'm going to keep doing this and adding. So the adding, the plus sign is indicated in formulas by a summation sign. This summation means a loop. You take each number minus the mean square, add, each number minus the mean square, add, and keep going until you're done with all the numbers. So now we're going to take the second number, which is minus 10, in parentheses, square. Now we take the third number, which is 0, and we square, which will be 0. And we divide now by that n minus 1. So let's take a look to see what is the n minus 1. Well, it's 3 minus 1. So it's 2. I'll just show 3 minus 1. Now, we're not done yet, because note, we squared all these guys. So now these values are inflated. They are much bigger than what they really were. Well, what we do to bring them back to their original dimension, we put a radical on top. As soon as we put that radical on top, here's the formula, it becomes the standard deviation. Okay, that's how we find the average of the error. So now let's find the real standard deviation for these three numbers. And of course, we don't take samples of 3. Okay, we take samples of probably 15 or more. In this case, then all we need is to take that square root, which is 100 plus 100, it is 200, and we divide by 2. So this becomes the square root of 100, and therefore the standard deviation equals 10. Okay, and that's how we found the standard deviation. Now, let's take a look at this example here. Cookies, good factories, good factories do they make a lot or a little errors? Well, it's a factory, they work day and night, and they work non-stop, so we guess they make a lot of stuff there, so they make a lot of errors. But are the errors large or small? Well, they're good factories, so they make a lot of small errors. Okay, very important to keep this in mind, that good factories make a lot of small errors. You take, for instance, pharmaceutical industry, they make certain medicines. Okay, so they might say, yeah, here's our medicine, and we put 200 milligrams of a certain active ingredient. What they really put in there is 201, and then they put 199, and then they put 203, 200, and a little less, but they are bouncing right around this 200 all day long, all night long, year round. They're bouncing here. Okay, so in the long run, the good factories have this type of bouncing, and you can see the width is very narrow. Now here would be a bad factory. The bad factory promises to put 200, but they can't control the process. Their machines or their workers are making a lot of errors, so they're putting 200, 180, 220, and therefore they bounce farther overall from the actual quantity they promised. So at the end of the day, the width here is much wider. So this means larger standard deviation. Okay, now let's take a look at some statements, some myths about the standard deviation. Incorrect ones, of course. Larger values have larger standard deviation. This is wrong. For instance, a sample of obese people will have larger standard deviation. Why? Think of it. If everybody is obese, then everybody is the same. The standard deviation is very small. That's why it's wrong. Okay? We don't need to know the standard deviation. The mean is enough. We hear this a lot in radio station, news, talking about the mean. This is very wrong. because this is what happens. Let's say I have an average of 30. Well, for this example, and I have another example here, the average 32. Now, when I have numbers bouncing far from the 30, let's say I have a 20, okay, and I have a 40. The average here is 30. Now here I have a 31 and I have a 29. The average here is 30. So in both cases they are 30. However, the quantities bounce farther in the first case. So the standard deviation here is very large because of this large bouncing. In the second case, the standard deviation is very small. Even though the mean is still 30, standard deviation is small. So you need to be aware of that it is incorrect to think that the mean can help you, and it can't. You need the standard deviation, okay? Standard deviation negative, not possible, all right? Because when we had our summation x minus x bar, okay, squared, you saw that I put a parenthesis around the numbers, okay? So this always gives us a positive. So you get all positive inside there. So there's no standard deviation that's negative. But in practical terms, there is no negative error. There is error. You put less medicine, the error is a positive quantity below the average. Okay. What you need to keep in mind is that the more the values differ from one another, the larger the standard deviation. Okay? The more equal they become, the smaller the standard deviation. Okay? When all the values are the same, then the standard deviation is 0. So let's say everybody got a 9 in the exam. Standard deviation is 0, the mean is 9. And the chart is this. That's it. Okay. Now, for the same example, let's say most people got a 9 and a few people got a little more than a 9 or a little less than a 9. The chart is this. Very skinny. This is a small standard deviation. Now, let's say the mean is a 9, but some people got much more than a 9 and some people got much less than a 9. So it widens up and the standard deviation is found right here. I'm doing this dot here to show you that we are talking about the length down here. When we say the standard deviation is 1 or 2 or 1.5, we're talking about here. But this dot on the curve, on this curve, indicates the second derivative of the function of x. If you had calculus, you know that the second derivative is when there is an inflection point and the curve changes from concavity down, in our case, to concavity up. Okay, so when you catch a second derivative equals 0, that's where the standard deviation is. Okay, but in statistics, we usually don't look at concavity and calculus stuff. We look at the x number line, and we find the distance from the 9, and this distance is the standard deviation. I hope this clarifies, and I hope you got a better idea of what standard deviation is, and good luck on your studies.